So number 4 asks us to evaluate the following integrals. So the first one, they want us to integrate from 1 to pi of this function, and this is going to be a power rule. So we can take the antiderivative and get 6t cubed divided by 3, and 6 divided by 3 is 2. Then minus 2t squared divided by 2, so the 2's are going to cancel, plus 3t. And we want to evaluate this from 1 to pi. So we plug in pi first. So it's 2 pi cubed minus pi squared plus 3 pi, and then minus 2 minus 1 plus 3. So 2 minus 1 is 1, 1 plus 3 is 4, so I can take this one more line. And we'll get minus 4. To evaluate the integral from 1 to x, well, once again, this is a power rule problem. So it's the same expression inside, so I'm going to get the same antiderivative as I got in part A. But now I'm evaluating it from 1 to x. So I'm going to plug x in first, and we get 2x cubed minus x squared plus 3x. And we already saw in the previous problem that when I plugged in 1, it turned out to be 4, so I'm still going to have my minus 4. Part C says, well, now take our answer from B and take the derivative of it. So everything in these parentheses is what we've calculated right here. So I can simply take the derivative with respect to x of my answer in part C. And I'll get 6x squared minus 2x plus 3. Now it's telling me in part D, well, if g of x is the answer to the integral from 1 to x, so if g of x is our answer from A, determine g of 2 and g prime of 2. So g of x is 2x cubed minus x squared plus 3x minus 4. So if I evaluate this at 2, I get 2 times 8 minus 4 plus 3 times 2, which is 6, minus 4. So this is 16 plus 6 minus 8, because my minus 4 and minus 4 add up to negative 8, and this works out to be 14. For g prime of 2, well, g prime of 2, if g of x is the result here, well, here when we took the derivative, this is g prime of x. So I'm simply going to plug 2 into this equation. So our g prime of x is gx squared minus 2x plus 3. So I'll get 6 times 2 squared, which 6 times 4 is 24, minus 2 times 4 is 8, plus 3, and I get 23. So now it says, use the fundamental theorem of calculus part 1 to determine d dx of this new function. So if we go back up and look what actually happened here. Well, when I evaluated the integral, I got an antiderivative, just as I've been doing all along. But look what happened when I took the derivative of the integral. So I took the antiderivative and then differentiated back. And the only thing that changed in our answers was the expression inside matched. It just changed the variable from a t to an x. So we got the exact same expression in the integral. So on something like this, where I might not be able to actually go through the steps and anti-differentiate all the steps out piece by piece, I know what should happen. This will become the antiderivative, capital F of t, and then as soon as you take the derivative of it and plug in x, you're just going to get this expression as a function of x. So the result is just x squared times the square root of 1 plus x squared. So it gets anti-differentiated, and then we take the derivative. And so just to kind of show you that in notation form, if you evaluate the integral, you would get capital f of x minus capital F of 1. And then when you take the derivative of that, you get little f of x, and the derivative of this is 0. So it just changes the expression, the variable in the expression.